So before I finally state the unit circle definition of the trigonometric function, I want to briefly extend what I talked about in the previous video about drawing angles in the plane in standard position. So let's say I had the xy plane and we want to draw some angle theta, which is equal to 45 degrees. So let's say theta is equal to 45 degrees. And let's say we want to draw this angle in standard position. Well, just like we talked about in the previous video, we imagine that we're a bug whose starting point is the point 1, 0, and then we walk 45 degrees along the unit circle, and then we stop, and then we draw the ray that extends from the origin and goes through that point where we stopped. And then the other leg of this angle, and we're drawing this angle in standard position. When we're drawing this angle in standard position, the other angle, one leg of this angle, that is, one leg of this angle is always the positive x-axis. So here's our angle in standard position, theta. But I sort of glossed over a key point here. When we're talking about angles, we define counterclockwise as positive, as the positive direction when we're talking about angles. And we define clockwise as the negative direction when we're talking about angles. So, let's say I wanted to draw the angle alpha, which is equal to negative 45 degrees. Well, I play the same game. I imagine myself as a bug. I start at the point 1, 0. I walk negative 45 degrees along the unit circle. And then when I finally reach negative 45 degrees, I stop. I draw the ray that goes from the origin through that point where I stopped. And then the other leg of this angle is, as always, the positive x-axis. And there's my negative 45 degree angle. Negative 45 degrees. So let's say also, we can see, keep going with this. Let's say I wanted to draw the angle beta, which is equal to 450 degrees. So this angle beta is greater than 360 degrees. So how would I draw it? Well, we're going to play the same game. As always, we're a bug that starts on the point 1, 0. We walk, we do our walk around the unit circle. We've reached 90 degrees. We've reached 180 degrees around the unit circle. We've reached 270. Then we've reached 360 degrees around the unit circle. But we haven't gotten to 450 degrees yet, so we just keep going until we get to 450. So we go 90 more degrees. Note that 360 degrees plus 90 degrees is equal to 450 degrees. So we keep going, and we finally reach 450 degrees. So we stop. We draw our ray from the origin that goes through the point where we stopped, and then we draw our ray that is the positive x-axis, and there's our 450 degree angle. But this just so happens when we draw this angle in standard position, the angle beta is the same when drawn in standard position as 90 degrees. That is to say, we say that these angles are coterminal. That is, we say 90 degrees, the 90 degree angle and 450 degree angle are coterminal. And all this means is when we draw these two angles, when we draw two coterminal angles in the standard position, like if I say that two angles are coterminal, then that means when I draw those two angles in standard position, then they look exactly the same. So we now have a way of drawing negative angles in standard position, positive angles in standard position, and moreover, angles that exceed 360 degrees in standard position. You could even extend this for angles that exceed 2 times 360 degrees, so 720 degrees. You just go around twice, and then whatever the remainder is, you keep walking up to that angle wherever, like let's say it's 750 degrees. Then we go around the unit circle twice, and then we walk 30 more degrees to get to 750. So now we're finally ready to talk about the unit circle definition of the trigonometric functions.